Welcome to the chapter 9 of 11th Physics, Mechanical Properties of Solids. By a rigid body, we generally mean a hard solid object having a definite shape and size. In reality, solid objects are not perfectly rigid. They can be stretched, compressed, and bent. When an external force is applied, a body may get deformed, and when the deforming force is removed, some bodies tend to regain their original size and shape, while others do not show any such tendency. So, on the basis of this one, let us define few terms to explain this behavior of bodies. Deforming force. If a force is applied on a body which is neither free to move nor free to rotate, the molecules of the body are forced to undergo a change in their relative positions. And as a result, the body may undergo a change in length, volume, or shape. A force which changes the size or shape of the body is called a deforming force. Elasticity. If a body regains its original size and shape after the removal of deforming force, it is said to be elastic body, and this property is called elasticity. For example, if we stretch a rubber band and release it, it snaps back to its original length. Similarly, in the case of a spring, as shown, perfectly elastic body. If a body regains its original size and shape completely and immediately after the removal of deforming force, it is said to be perfectly elastic body. The nearest approach to a perfectly elastic body is quartz fiber. Plasticity. If a body doesn't regain its original size and shape even after the removal of deforming force, it is said to be a plastic body, and the property is known as plasticity. For example, if we stretch a piece of chewing gum and release it, it will not regain its original size and shape. Perfectly plastic body. If a body doesn't show any tendency to regain its original size and shape even after the removal of deforming force, it is said to be a perfectly plastic body. Putty and paraffin wax are nearly perfectly plastic bodies. Note that no body is perfectly elastic or perfectly plastic. All the bodies found in the nature lie in between these two limits. When the elastic behavior of a body decreases, its plastic behavior increases. Stress. If a body gets deformed under the action of an external force, then at each section of the body, an internal force of reaction is set up, which tends to restore the body into its original state. The internal restoring force set up per unit area of cross-section of the deformed body is called stress. And as the restoring force is equal and opposite to external deforming force, so we can say that the stress is equals to applied force divided by. Mathematically, stress is equals to force upon area. Therefore, its SI unit will be Newton per meter square and CGS unit is Dyne per centimeter square. The dimensional formula therefore will be mL-1 T-2. Types of stress. Longitudinal stress. If the restoring force set up per unit cross-sectional area of a body, when the length of the body increases in the direction of the deforming force, it is called longitudinal stress or the tensile stress. Compressional stress. If the restoring force set up per unit cross-sectional area of a body, when its length decreases under a deforming force, then such type of stress is known as compressional stress. Tangential or shearing stress. If deforming force acts tangentially to the surface of the body, it produces a change in the shape of the body. The tangential force applied per unit area is equals to the tangential stress. Now, normal stress. If the body is subjected to a uniform force from all the sides, then the corresponding stress is known as hydrostatic stress or the normal stress. For example, consider a rubber ball, and if it is dipped in the pond, due to the pressure of water from all the directions force it to the ball, as a result the ball seems to be slightly contracted. Because of the force exerted by the water, there is restoring force which develops in the ball, which is equal in the magnitude of the force applied by the water, but in opposite direction. This type of stress is known as hydraulic, or you can say hydrostatic stress.